In this video, we're going to learn how to calculate the net present value, or NPV for short, using this example that you're seeing on your screen. So the example says an investment has the following cash flows. So year 0, the cash flow is 400,000. I want you to note that every time an investment or an amount is shown with brackets, it simply means it's an outflow. So we have inflows and outflows. Outflows are simply the money that is being spent, and inflows, this is the money that is being generated. So in year 1, we have 70,000. In year 2, we have 120,000. In year 3, we have 140,000. In year 4, we have 140,000. And year 5, we have 40,000. And the question says, given that the opportunity cost of capital is 8%, so opportunity cost is the same as discount rate. Probably you have seen other literature that calls this the discount rate. It's the same thing. The discount rate and the opportunity cost of capital is the same thing. The two terms are synonymous. So we have the opportunity cost of capital at 8%. So the question is, we calculate the net present value and make a decision as to whether to accept or reject the project. The formula for calculating the present value is the future value multiplied by 1 over 1 plus k raised to the power n, where k is the discount rate. So this formula, we can rewrite this formula as this for easy representation. And in solving this question, I am going to use a table so that you are able to project, and it makes things easier to flow with when we're working with a table. So for the different years that we have from year 0 up to year 5, we are going to indicate the cash flows that we were given in the question. And then I have made the third column to represent this part of the equation, the 1 plus k raised to the power negative n, so that we tabulate the values that we'll get, that we are going to multiply times the future value. So also this is done for easy representation. So for year 0, when we put 0 here, that is 1.08 raised to the power negative 0, we know from indices that any number raised to the power 0 is equal to 1. So that will give us 1. And then for year 2, we'll have that value. And if you notice, I have increased the number of decimal places. This is so that when I make the multiplication of the future value and the 1 plus r raised to the power negative n, the value that we should get for the PV should be more accurate. This is why I have increased the number of decimal places. So for year 2 and year 3, those are the values. Year 4 and year 5, those are the values that you'll get. Please make sure also to verify these numbers. And then in order for us to get the present value, we are going to multiply the cash flow or the future value times 1 or times what we have here, so that we get the present value, just as represented in the equation. So for year 0, we have 400,000 or negative 400,000. And then for year 1, we have that value. For year 2, we have that value. For year 3, we have this value. Year 4 and year 5, that's the value that we are going to get. So in order for us to find the net present value, the net present value is simply the summation of all these values. To say this another way, the net present value is simply the total amount of the present values minus the investment cost. Or let me say this another way also. The net present value is simply the cash inflows minus the cash outflows. I think that one is a simpler one and easier to understand. So we'll add all our inflows, that is from year 1 to year 5, and then subtracted by our outflow, which is the 400,000 for year one. That will give us our net present value. And the net present value in this case is 8,959. And remember the second part of the question. The second part of the question was we should make a decision whether to accept or reject the project. So given that the net present value is positive, we are going to accept the project, or the project will be accepted. If this value was negative, then we would not accept the project. Thank you very much for watching. Please make sure to subscribe to our channel for more videos like this.